Alright, hello everyone, it's me Matthew again, and today we're in the Sets and Maps module. So today we're going to be going over the degree of a string problem. And before we go into the problem, again, I just want to reiterate what our 3 steps were for solving these problems. So the first step was, of course, to understand the problem. Then our second step was to come up with a solution. And the third step, of course, was to optimize the problem or optimize the solution if there were any. So with that out of the way, let's just get into the problem. So the problem statement says that we're given a string str, and the degree of a string is defined as the maximum frequency of any one of its characters. And our task is to find the minimum length of a contiguous substring of str that has the same degree as str. Okay, and so remember that a contiguous substring just contains 2 indexes, and it has all of the elements from I to j. So let's look at the first example. We're given this string, and the output is 4. And the explanation says that the maximum frequency is 2, and that makes sense because the letter T has frequency 2. And the smallest contiguous substring that has frequency 2 is THAT, which has length 4. And we look at the second example, and the output is 7. The maximum frequency is 3, and we should note that capital H and lowercase h are considered to be different characters. So the greatest frequency in this string is 3 because the lowercase h appears 3 times. So the smallest contiguous substring is just the entire string, which has length 7. And it's similar things as well with these examples as well. The letter S appears twice, and every other character appears once. So we just see that this is the smallest contiguous substring with degree 2 as well. And same thing for this example. N appears twice and every other character appears once. So there's this contiguous substring with length 4. And then once again for the last example, S, T, and L appear once, but it looks like A and N and 0 appeared twice. However, the character 0 appears twice, and it's in a smaller contiguous substring than the one with N and the one with A. So the output is 2. And then some constraints to note are that the length of the string is allowed to be 0, so we have to consider the empty string when we're constructing our solution, and then there's just some upper bound on the length of the string. And we also should note that the string only consists of alphanumeric characters, so we only have to worry about letters and numbers. Okay, so now that we have a feel for the problem, we should start coming up with just a naive solution, right? So we want to find the minimum length of a contiguous substring that has the same degree as str. So one thing we might be able to do, let's just write this down. First solution is just get the degree of the string, right? So get degree of str. And then what we're going to want to do is look through every single contiguous substring of str and find a substring that has the same degree as str and also has the smallest length. So we iterate through each contiguous substring and then find a contiguous substring with largest degree. And by largest degree, it's actually just the degree of str. So with degree of str and smallest length. And then for our fourth step, all we have to do is just return the smallest length. So let's just go over our first solution with the first example here. So we would get the degree of str, and we would note that it has frequency 2, or at least T has frequency 2, so the degree of str is 2. And then we would go through every single possible substring or contiguous substring of str, and we would see that THAT is the smallest contiguous substring that also has degree 2. And so we would put 4 for the smallest length, and then we would just return it. So our first solution seems to make some good sense, so I think we should just go ahead and start coding it. So let's just have an int, and we're just going to call this the max degree. And we're going to have some function, just find degree, and it's going to take in a string and it's going to return the degree of the string. For now, we'll keep this as an abstraction, and then we'll implement it after we've finished. And then we're going to have an int called min size for the smallest length of the subarray, and we're just going to initialize that to be just the size of the string. So then we've completed step 1, we've gotten the degree of str. Then what we want to do is iterate through each contiguous substring. So what we want to do is just choose an index I and iterate through every single element, and then we're going to get another index that starts at I and is also less than the size, and then we're just going to iterate through that. So this is how we get the substring first. So we're also going to want to get the size of the substring, and that's just going to be j minus I plus 1. And then using the substring function, we're just going to get the string, or the substring itself. So string, and then dot substring, and it starts at index I, and it has size of size. And let's just label this substring. Great. And once we have the substring, we should also get the degree of the substring. So int degree is equal to find degree of the substring. And remember, we said we're going to worry about this later. For now, we're just going to assume it gives us the correct degree. So we have the contiguous substring, and now we're going to find a contiguous substring that has the same degree and the smallest length. So we want to make sure that the degree is equal to the max degree. And if this condition is true, then we're going to say the minimum size is just the minimum between whatever we currently have for the smallest contiguous substring and the size of the current substring that we have right now. And that's what we would all really need to do, since we don't need to update the degree because we already have the maximum degree, and we're just updating the size itself. So that's all for finding the contiguous substring, and then we would just return the minimum size once we're done iterating through every single contiguous substring. So now that we have most of the algorithm fleshed out, let's just create the find degree method. So int find degree, and it'll take in a string. So now we have to wonder, well, how are we going to find the largest character frequency in the string? Well, if we look back at the first module, this is pretty similar to what we did for the isomorphic strings problem, where we used an array to count the frequency of each character in the string. However, this time, we're not going to use just an array because, remember, the constraints said that we're using alphanumeric characters. So we have a larger range, so it would actually just be better if we used a hash map, or in C++, an unordered map. So we're going to include that up here at the top, unordered map. And this unordered map is going to map each character to its frequency. So we're going to initialize it to be, the key values are going to be charged, and the values themselves are going to be ints. And let's just call this frequency map. And we're also going to have a degree value that just keeps track of the current degree of the string, and we're just initializing that to 0. So then what we're going to do is we're going to iterate through each string, or through each character in string, and record the frequency. So we're going to increment it whenever we encounter a certain character, and at the end of this iteration we're going to have all the frequencies themselves, and then we're just going to return the largest one. So let's go ahead and do that for char c and str. And what we're going to do is, if we haven't encountered this, then the function count would return false. So what we're going to do is just go frequency map, and we're going to initialize that value to be 1. And if we have already encountered it, then like we said, we're just going to increment the count to be 1. So that's it so far. Then what we need to do is find the largest degree out of this entire frequency map. So let's just go ahead and keep it simple. So we're just going to iterate through every single pair in the frequency map. And we're going to say degree is equal to the largest between itself and the second int in the pair. And remember, the int is just the frequency. So we're comparing this to every single frequency in the string, every single character frequency. And so at the end of this for loop, we're going to have the largest character frequency, and that'll be the degree of the string. So that's exactly what we're going to return. So let's just go ahead and see if this algorithm would work for something like this string str. So we start off with h, and h isn't in the frequency map, so we say that it has a degree or a frequency of 1. Then we would go to I also is not in the frequency map, so we say that that's 1. And then we say uppercase h. And remember, we're distinguishing uppercase h from lowercase h, so it's also not in the map. So we say that the frequency is also 1. And then we see I as well. It also is in the map as well. So we're just going to say increment that frequency value. And then we do the same for G, H, and H. And at the end, we should see that H has a frequency of 3. So once we iterate through this entire frequency map, we should see that H gives us the largest frequency. So we're going to make that the degree, and we're just going to return it. So that's really the find degree function, and that's all I think we had to do for this function now. So before we submit it, let's just do one more example and really make sure that our algorithm is working. So we're going to do this max degree function on stylish, and it's going to return 2 because the letter S appears twice. And then we're just going to initialize the minimum size to just be the size of the string. Then we're going to go through every single contiguous substring, and eventually we should find that this substring has degree 2, and we should also find that it is the smallest substring as well because of this minimum function. And so once we do that, we continue iterating through every single other contiguous substring, and what we do is we return the minimum size. And since we said the minimum size was just going to be this length of 6, that's exactly what it returns. So this algorithm makes sense. I don't think there are any bugs, but we'll find out in a second. So what we're going to do is just go ahead and test it against the other test cases and hope that it's correct. Okay, and perfect. All test cases passed. And look at that. Even though we didn't necessarily consider the empty case, we can go ahead and say that it actually does pass an empty string case as well, because the degree of the string would also just return 0, and we would declare the minimum size to be 0. And then we're going to do this for loop, and it doesn't really execute, so we return 0 as well. And it also does the same for every single other string. So our algorithm works, and like we said before, just because we came up with a solution doesn't necessarily mean that we're done. So let's go ahead and see if our degree of string algorithm is really efficient. So like we said, we're going to evaluate the time complexity and the space complexity. So the first thing that we do is we get the max degree of str, and we use this find degree function. So let's go ahead and analyze the find degree function as well in terms of time and space. So time and space. So we're given this string for the find degree function, and the first two things that we do are initialize the frequency map and the degree. Now these are both just constant time operations, so we don't need to worry about them. Then the next thing we do is iterate through this for loop, and we're iterating through every single character in the string. So it seems as if we're doing some at least linear operation on the string. And then we see within the for loop, we're doing only constant time operations. Since remember, with hash maps, we use this hash function to go ahead and get the key value pair. So accessing and looking up whether a character is in the hash map shouldn't be a big deal, and these should all just be O of 1 operations. So this entire for loop should just be O of n. And then once again, we're iterating through every single character in frequency map. The worst case is that we iterate through all of str since each character is unique. So this is also just O of n. And then at the end, we're just returning the degree. So in terms of time complexity, this function is just O of n. Now in terms of space complexity, remember we said the worst case for this for loop when we iterate through frequency map is if each character is unique. So it's possible that this frequency map grows at the same rate of the string itself, and we're going to say that the space complexity is also O of n, where n is just the length of str. So immediately off the bat, for our degree of string function, we know since the find degree function is O of n in terms of time and space, we have an O of n time complexity at least. And then we just get the minimum size, which is just a constant time operation. And then we have this for loop here, which might be a bit intimidating to look at just first because this condition doesn't really seem all that bad. But then we get here and then we see that the number of iterations really depends on I, and it's not just a simple condition where we start at 0. So what we're going to want to do first is remember what this for loop is actually doing. So remember how we said that we wanted to look through every single contiguous substring? Well, one thing that might be helpful would be to consider how many contiguous substrings there are of a string of certain length. So we're going to say that str has length n, right? And what we're doing within this for loop is we're choosing 2 indexes of str, and we're saying that that is the contiguous substring. And since we're going through every single contiguous substring, we're going through every possible pair of indices in str. And so this now becomes a combinatorics question. And you might remember, well, how many times can I choose 2 from a set of n, right? And this is just the choose function. So we're doing n choose 2 iterations, which is just n times n minus 1 over 2. So that's at least how many iterations we're doing on the substrings themselves. And then we're getting the substring, and we're using this find degree function, which is also just an O of n operation. And everything else, well, getting the substring is also an O of n operation, so let's just write that down. O of n in terms of time complexity, and where n is the size of the string. And getting the size is constant, and so is just this if statement itself. So we're getting each substring, and then we're doing an O of n operation on it. So it seems as if this for loop is O of n cubed, since we're getting O of n squared substrings, and then we're doing an O of n operation on it. So we just multiply it and get this time complexity itself. Now in terms of space, since we're doing the find degree function, remember we said it had an O of n space complexity. So this is also just O of n for space. So that's all we have left within this function, because at the end we just return it. So the overall time complexity is O of n cubed, whereas the overall space complexity is O of n. So it is looking a bit rough since we're doing a lot of iterations, or it's at least quadratic time, just based on the length of the string itself. So you might want to think, okay, is there any way that I can optimize this? And the best way to start looking at it is just to see what the bottleneck of your algorithm is. So what we're doing within this loop that's causing an n cubed time complexity is we're iterating through every single contiguous substring of a string. So you might want to ask, well, is there a way for me to get the same result without going through every single contiguous substring? And there probably is. So remember, what we're doing is we're finding the smallest contiguous substring with minimum length. So let's just go ahead and relook at these examples and see if there's anything else that we're missing. So we see that the smallest possible contiguous substring that has the same degree is THAT. And one thing you might note is that the first and last characters, they're the same characters. And that makes sense, right? Because if we had THAT and we just appended any more characters to it, well then we're not going to add anything to the degree, since all the T's are in this specific area. So you might think that for a minimum contiguous substring for a certain frequency, you just want to get, or for a certain character, you want the first and last indexes, or the first and last characters of that contiguous substring to be the same. And that would be a pretty good guess, because we look at this other example as well, and we note that the smallest contiguous substring, they also have the same characters. We look at that again here, and again in all the other examples. And so this intuition seems to be a prominent characteristic of the minimum length of the contiguous substring. And it makes sense, right? Because if we have all the characters, and let's say we have index I, and that's the first instance of a character, and we have index j, which is the last index of a character, we're not going to want to consider any other indexes beyond those. We're only going to want to consider the ones between I and between j. And that way we have the minimum length of this contiguous substring. So now that we have this fact, we can kind of note that it's the same for every single character, right? The smallest contiguous substring that contains all the f's is just the substring f itself. And same for L, 1, P, and if we go to this example as well, the smallest contiguous substring that contains I, or for I, is just the first and last instance, and then we get all the characters in between. And so we can kind of use this intuition on the smallest contiguous substring that has the same degree, and we can find the first and last index of each character in the string. And so from that, we can also record the degree or the frequency of each character, and then return the length that is the smallest and has the highest degree. So I kind of said a lot there, so first I'm just going to comment this out, and then I'm going to restate what I said. So second solution. The first thing was just record the first and last index of each character. And remember what we said, this is just to find the smallest contiguous substring, which contains the most amount of these characters. And then we're also going to want to record the frequency of each character. And then once we're done recording all of these things, we're just going to return the, we're going to want to return the length of smallest substring that has the highest frequency. So that has highest frequency. Okay, so this algorithm makes sense. And let's just go through it with another example right here. So let's go on example 5. So we're going to record the first and last index of each character, right? So S, first and last index is 1, T, or first and last index is 0, and T1A has its first index here and its last index here. And then same for N is over here, and N is also over there. And while we're doing this, we can also record the frequency of each character. And so we do the same for L and for 0, 0. So then at the end, we're returning the length of the smallest substring, and we can get the length of the smallest substring from this first and last index that we've just recorded. And we'll find out that the length of the smallest substring is with zeros, with these zeros right here. And it'll also have the same frequency as str, or it'll have the greatest frequency out of all the other substrings. And so that's what we would end up returning, the length of it, which is just 2. So our algorithm looks like it makes sense, and we've thought about it, and we've determined that it is correct. So let's just go ahead and churn out the solution right now. So we're going to want to record the first and last index of each character. So we can, again, do that with just an unordered map. And the first key is just going to be a character, and the value is going to be a pair. And it's going to be a pair of ints, where the first int is the first index and the last int is the last index. And let's just call this the index map. And then we're going to have another unordered map, and it's going to map each character to its frequency. So char and then int. And then, like we said, we're just going to call this a frequency map. And we're going to have 2 more variables. Let's just call this max degree. And it's going to be similar to what we did in the previous solution, where we just have the variables for the degree and the size. So min size, or actually that's not, yeah. We're going to declare it to be the size of the string itself. And at the end, we're going to be returning the minimum size. So we have these variables initialized, and we're going to go ahead and do these first 2 steps. So we're going to iterate through each character in str. And actually, before we do that, let's just make an int for the index. Now you could have also done this with just a normal for loop, but I'm just going to do it with an enhanced for loop just because it makes my life easier. So we're going to have that, and first thing, record the first and last index of each character. So what we can do is just say, if this character is not in the index map, then we haven't encountered it before. So if not index map.count c, then we haven't encountered it before. So we're going to update the index map as well as the frequency map, since we're updating these both simultaneously. So index map c is just going to be a pair of ints, and the first and last occurrence that we know of right now is just at the index we are currently at. And then the same for the frequency map. We're just going to initialize that to just be 1. Now, the second case is where we haven't, or where we have already encountered this. So all we need to do in terms of the index map is update the last index of where we see it. So we're going to go index map c, and then dot second is equal to the current index we're at right now. And then we're just going to increment the frequency itself, since we've encountered it again, to 1. And at the end, what we're going to want to do is increment index itself, so that we have the proper indexes for the index map. And once we're done with this for loop, we should have successfully recorded the first and last index of each character, as well as record the frequency of each character. So now we're going to go into the third step, which is just to return the length of the smallest substring that has the highest frequency. So what we're going to do now is just reiterate through one of these maps. It really doesn't matter, but let's just go ahead and iterate through the index map. So we're going to go auto pair into index map. And we're just going to say that char c is pair.first, and that the size is pair.second. So remember, we're getting the pair itself, and then we're getting the last index of it, and then we're subtracting it from the first index, and then we're just adding 1 to get the proper size. So now we have the proper size of it. We're also going to want to get the frequency, so we can just say frequency map c. So now we have all the correct variables that we need to adjust the max degree and the minimum size. So we're going to say if the frequency is greater than the maximum degree, then we have a new degree for str. So we're going to say max degree is equal to frequency. And after we do that, we're just going to reinitialize minimum size to be the size we currently have. Now, we have one more situation or two more, but one more that we're going to consider, where the frequency is equal to the maximum degree. And this is similar to the situation we have in the fifth example, where we have multiple substrings that have degree 2, but we have this double zero, which is smaller than any of the other ones. So what we're going to do is just say the minimum size is equal to the minimum between itself and the current size that we have. And in the case where the frequency is less than the maximum degree, well, then we don't really care because we only want to find the contiguous substring that has the same degree or more than the current degree. So at the end of this for loop, remember we said we were just going to find the smallest substring that has the highest frequency. And I think that's all we have to do for this loop right now, right? So we get the frequency and the size, we check that against the current max degree, and we update if necessary. So then all we have to do at the end is return the minimum size. So again, before we check this algorithm, let's just go ahead and do our own self-run. And I'm just gonna keep track of some variables here to make it easier for us. So we're gonna do this with example 5. And we're going to have index map as well as the frequency map. And then we're going to have the max degree as well and the minimum size. So the first thing we're going to do is just initialize these variables here. Then we're going to do one whole iteration through the string. So we're going to see s, and we're going to note that our index map is empty, so of course it doesn't have anything. So we're going to say s is now at 0, 0, since that's the index we're currently at. And that's the first time we've seen this. And then we're going to also say the same for the frequency map. S is just mapped to 1. Then we increment the index. And actually, let's just make an index, right? So yeah, now we're on the first index. Then we go to t. We haven't encountered t, so t is just at 1, 1. That's how much we've seen it, or that's the indexes of where we've seen it so far. And then we're going to add t to the frequency map. So t, 1. And then we're going to do the same for a while we increment index a to, or actually it should be capital. Oopsies. Yeah. So we have that, sta, and then 2, 2. And then the same for the frequency map. A, we've only seen it once. Then we go to n, and we should also increment index, and we see 3, 3. And then once again, we've only seen n once. Then we go again, one more for L. L is at 4, 4. And then we just see L once. Then we go to 0, once more, 0. We've seen that at index 5. And 0 once. And then we go to the next character, and actually we've been neglecting this index. Now we're at index 6. So we go to the next character, and we see 0. So we go into this else statement actually, and we say that the second is equal to the current index. So we update this to just be 6. And we also increment the frequency as well, 2. And so we go to the next character after that, and we increment index, and now we're at n. So we go ahead and say the second index is 7, and we've now seen n twice. And then we go to the last, which is just a. We increment this, and we see that a is seen at 2, and the last is at 8. And a, where is a? Where are you? Okay, 2. Yeah, and then the last thing we would do is just iterate through this entire index map again, and we would just update it, these max degree and min size, with the largest degree, which we would find 2, n, and a, as well as the others, but these are the most important. And then we'd find their first and last index, and we would see that 5 and 6, that's going to be a substring of 2 of length 2. And we're going to put that into max degree and max size. So our algorithm looks like it should work. It doesn't seem like there are any bugs, and if there are, then we're going to debug it itself. But yeah, let's just go ahead and see if it behaves properly and if it passes all the test cases. All right, perfect. No bugs, no anything, and our algorithm seems to be working. And let's just check how efficient it is, right? So right off the bat, I think we already knew that this was going to be a little bit more efficient since we're just doing these for loops here. But let's just go ahead and see how much more efficient it is so we can really bask in all of its glory. So let's get the time complexity and the space complexity. So we see that the time complexity of just initializing these variables, they're all O of 1 so far, as well as with this index. Then we're going to go ahead and do this entire for loop. So we're going to iterate through every single length or every single character of string. So we're going to go through the length of str, which we're just going to say is n. Then we're going to check if it's inside of the hash map. And remember, hash maps have O of 1 accessing time. So this is just constant time operation. And everything inside of these if statements are also just constant time. So this entire for loop is just O of n, where n is the size of the string. And then once again, we're going through every single character or through every single pair in index map. And like we said previously in the last solution, the worst case was where every single character is unique, and so we iterate through the entire string. So this is also just O of n. And every single statement inside of here is also O of n, so we don't need to worry about anything else. And lastly, we're just returning the minimum size. So the time complexity of n, which is great. Give yourself a pat on the back for thinking of that, because that's a lot greater than n cubed. And the space complexity as well. All we're doing is storing the character and 2 indexes for it, as well as the character and its frequency. And in the worst case, like we said, we're storing this for every single character. So this is also just O of n. And so the time complexity of our new solution was just O of n, and so is the space. So at the end of the day, we can see how much hash maps can really save you in terms of time. And that's really just what I want you to take away from this video. So you're able to do this problem, give yourself a pat on the back, and that's all I have to do for today. So thank you everyone for watching, and have a nice day.